All right, welcome back, everybody. This is Brian with zen.passion.adventure, and this is lesson 2, how to design and draft a solar project for permit. From beginning to end, I'm going to teach you how to do a solar plan to bring to the city and get a permit to do your solar project. And so yesterday we went over lesson 1, setting up the solar project, and I told you need draft site. We went over the Google Maps, everything we needed online, Zillow.com, public information. We went over the data sheets, and also we went over this checklist of all the equipment and everything to prepare the project. We created the project folder. We searched for the home in Google. We did the screenshot of the vicinity of the roof, satellite view, so that we could draft the home, and took a screenshot of the Zillow page, and also we added the equipment data sheets to the project folder, and we also deleted all the files that we did not need from the old project folder. So the panel module data sheet, the inverter data sheet, their attachment, and the rail. And so now today this lesson is going through each of the pages. Page 1, 2, 3 are the pages that you'll spend most of the time on: the title sheet, the equipment plan, all the structural details, the electrical wiring diagram. And then the rest of the sheets are just changing customer information and making sure that the JPEG is placed properly on the data sheets. And then finally the warning placards. So I think the way that I might do this is just take you through all the sheets. This is the way that I complete a plan. I just change all the customer information on every single page. Page 1, page 2, page 3, page 4, 5, 6, 7, and the warning placards. I change all the customer information, and then later on I go back and I do the calculations on the electrical wiring diagram. And then after I do the calculations and do the electrical wiring diagram, I draft the project and place it in the title sheet and the equipment plan. So I'm going to take you through and teach you this as I normally complete a solar plan for myself. So let's do that right now. Get out of the PowerPoint. We have our training actions up, and let's get into it. Here's our DOE project from lesson 1. Here's our project folder. And we're going into the first page. We're completely offline. If you notice, we're completely offline. We won't be needing the internet until the end when we merge and compress all of the PDF files. Again, we're going to be changing all the information on each one of these draft site drawing files, and we're going to be creating a PDF of each one of these draft site drawing files. So let's do it. Open draft site. Draft site is a free program and you can download it for yourself. It's a 2-dimensional drafting program by Dassault Systems. They also make several 3D modeling CAD programs. Okay, so we have our page 1. I'm going to delete all of the items that we will not be needing. And I take all of these labels from the old project and I just move them over to the left hand side here off of the page. And see, these are the JPEGs for the old project. Since the JPEGs are no longer there, draft site is trying to find them, and it's just returning the address of where they are at instead of actually presenting the JPEG files. We're going to be putting new JPEG files, so we'll delete those. So this is page 1. And okay, let's get into it. This is an owner build, so no contractor. And let's change our customer information. I like to put, this is the John Doe residence. Cities and the electric companies sometimes require that the name be on there exactly as it is on the electric bill. So it's some jurisdictions and some electric companies. Not all electric companies require that. So 655 Oak Circle. And this is Pleasanton, California, 94566. 858 555 2562. There it is. Okay, today's date, 24th. The parcel number. See, this is where we need that Zillow file. And so I go into my folder, open up the Zillow for Doe. And usually the parcel number is there. I am going to have to call the city to get that parcel number. Not all cities require that the parcel number be on the plans. And so I'm just going to delete it for right now. Lot size is 0.026 acres. 0.26 acres. Floor size is 2,500 square feet. Okay, so that's what we need the Zillow file for. We no longer need the Zillow file. Okay, now we get into the PV system specifications. This lists all of the equipment we're using. So we are using LG 300 watt. I like to put 300 watt, and then here is where I put the actual name of the model type, model number, 300N1C. And we want how many of these? We want 28 of these. Then we have a SMA Sunny Boy inverter, SB8000TL we're going to be using on this project. One of those. We have quick mount attachments and Unirack rail, 20-degree tilt, 170-degree azimuth. And so the power rating, DC power rating, all that is the wattage of the panels multiplied by how many panels you're using. That's the number of watts, and so we need to change that to kilowatts. So right now we have 28 panels multiplied by 300 watts, and that's 8.4 kilowatts, 8,400 watts, 8.4 kilowatts. Very good size system. So that's the PV specifications, system specifications. Now we go on to code compliance. This is notes stating that we are following National Electric Code, the newest version. It will change. It just changed this year to 2016 version. California Fire Code, San Diego Fire Code, County Fire Code, and the California Residential Code. These are all laws that we're abiding by and that we are building to. So this one will be, then we go into project jurisdiction. This one we are submitting to the city of Pleasanton, California. So we need to change this to Pleasanton. City of Pleasanton. That's an A right there. Pleasanton, California. So we do need to go online to get this address. As I had stated before, I thought we were all done, but we did not get that address before. So we need to get that address for the city of Pleasanton, California. So let's go online really quick and we can just copy it over. City of Pleasanton, California. Permit, I like to do building permit. Permit center. Okay, here it is. 200 Old Bernal Avenue. I'm going to go into this web. Okay, I'm in the website now, and sometimes it has phone numbers that I will also need. So here we are, City of Pleasanton, California, 200 Old Bernal Avenue. 200 Old Bernal. This is also where the client will go to submit this for the permit. Pleasanton, California, 94566. Phone number. Permit applications 925. I just do the first phone number that I see there. 925 931 5300. If somebody to contact. Okay, that's the city. I do have a library of all the cities, and so I copied this and I'm saving it right now. And I do have I keep a running library of all the cities that I've done projects for. So these are all the cities that I've done projects for. This is the San Francisco Bay Area, so we're going to place the City of Pleasanton here. There's a City of Pleasanton. So I like to keep this library because I go to it fast to copy and paste and to place in this box. Okay, next we have the sheet index. We have a title sheet, the equipment plan, the electrical diagram, and then we have the data sheets again, and then we have the warning placards. It's like a table of contents. Next we have the scope of work. Now this scope of work has to read properly. Okay, they want to know what you are trying to accomplish with this construction plan. This project consists of the installation of 28 photovoltaic modules with one utility interactive inverter. Sometimes you have to change that to microinverters if you're using microinverters. PV modules, PV stands for photovoltaic, will be mounted to an existing composite roof type. Let's get offline here. We have composite rooftop using quick mount attachments and Unirac rail. Those things are all true. And then this is just a note, the attachment system is specifically designed to withstand 110 mile-an-hour loads and seismic loads on existing rooftops. Refer to code compliant installation manual for detailed information and waterproofing specifications. Okay, now we're going to place some JPEGs into our drawing file here. So we have the vicinity map is the first JPEG. If you see, we have a note here. I like to keep that note. I'll show you. Let's see, insert reference image. This is a command to place a JPEG. So we go into our DOE folder, we go into our project folder. All of the JPEGs that we're using in these drawing files need to be in the same folder. So otherwise draft site cannot see them. So here's our vicinity map for DOE. Yes, that is the JPEG that I would like to attach. Now for this, I like to use the snap function. This snap function, you can snap to any, it's asking you where do you want the start position of the JPEG. So I'd like to snap it to that endpoint right there. Easily snaps there. And I like to have it fill as much of this box as possible. So there it is. There we place the JPEG. We can select the JPEG. We can copy, we can move, we can manipulate the JPEG any way that we like. I like to move it and I like to center it here. This is where I turn my snap off because I don't want it snapping to something inadvertently over here. So I hit the button and I'm now moving. I can now move it. And I can hit another thing, great feature of DraftSight, I can hit the shift button, hold down the shift button, and it will move it exactly left to right or up and down. This is called an orthographic snap. See, by hitting the shift button, I trigger this snap as well. So I like to use this because it is more exacting. So I just hit escape to get out of that function. So I'm going to select it again, move, and I want to center it there. I believe that's pretty centered. Now, as you notice, the JPEG is covering our label there, project location. So what I do is I select the JPEG, I right mouse button click, and it says display order. I like to send this JPEG to the back, and all of a sudden you can see our label now. I like to place this label anywhere so it's not obstructing any other labels. And so there, we've placed the vicinity map. Now I like to insert the roof view here so people can see the roof view. Yes, that is the JPEG I would like to attach. You can see the roof view and our drafted view. So I like to make that the sizing almost the same size as that box. And I select the JPEG, right mouse button click, I can move it. I like to use my snap here, and I like to snap this corner all the way up into this corner here. I like to snap it right to that line. So there, we've placed the vicinity JPEG and we've placed the roof JPEG so people can see the satellite view, what it looks like in real life. Now, next I save it. I save continuously just in case draft site shuts down on me for some reason. Okay, now this is information about the modules, the weight, the roof type, again, number of stories of the home, roof framing, spacing of those rafters, and structural type single family residence, number of roofs we're using, and stringing. I like to place the stringing on here so people can see on the very first page what the electrical stringing is. So we'll figure out that in a second here. So let's make sure these module dimensions are correct. Let's go to our data sheet. All the information about our project we can find on our data sheets. So this is the module data sheet, and then if we want any electrical information, we have the inverter data sheet here, and we have also electrical information on this module data sheet. So there's our 300 watt. So right here are the mechanical properties of our panel modules. Let's just verify. Okay. So our panels are length 1640 millimeters, 1000 millimeters in width, and 35 millimeters in height. So everything in the US, they like to have inches, and so let's convert 1640 millimeters to inches. So 1640 millimeters is 64.57 inches. So that works out. Now we're going to do 1000 millimeters. Let's try 1000 millimeters. It's 39.37 inches. So that is equal to the last project that we did. So our weight is 16.8 kilograms. So let's change kilograms to pounds. It's 37.03 pounds. We're going to do it 37.04 actually. So let's change that. Roof type is composite. Number of stories, that looks like a single story. That's a single story home. Roof framing, 2 by 6. Let's see, we have here 2 by 6 at 24 inches on center. This is not the truss. The truss of the home actually goes through. That's the roof truss. These are rafters and trusses. So we have to watch out our verbiage. 24 inches on center spacing. Structural type is a single family residence. Number of roofs we're using. We're going to put the solar on this roof here. So only one roof. I believe all 28 can fit, and we can verify that when we draft out the project. So we're only going to be using one roof. Now the stringing is special. For the stringing, you like to have the strings balanced. Number one, you want as many panels in the string as possible. Number two, you want to keep them balanced. As many panels in the string as possible. You want to make sure as many panels in the string as possible, you want to make sure that you do not go over the input voltage going into this inverter. So we have to check the inverter voltage, how many volts can we put in, and how many. This will determine how many panels per string that we can have. So we have 28 panels. Let's see if we can have 28 panels all on the same string. When the panels are in series, the voltages add up. When the panels are in parallel, this is electrical class 101. When the panels are in parallel, the voltages stay the same. So one string is in series. So let's check. Each panel, we take the highest voltage, 300 watts. We're using 300 watt panels. The highest voltage here is the VOC, open circuit voltage. And we have 39.5 volts. So it's 39.5. Say we use all 28 panels in one string. That's 1,106 volts. Okay? Now let's see if our inverter can handle it. Let's pull up our inverter data sheet. Looking for the 8000 TL. What you don't see here are the labels on the side. Our inverter can only handle 600 volts. If you have the labels on the side here, you'd be able to see that the maximum voltage that this inverter can have input. This is input, this is output. Can handle 600 volts, and we have over 1100 volts going into the inverter. So we can't have that. We need to split the modules up into two strings at least. Let's see. 28 divided by 2 strings. 14 panels per string. So we can have two strings of 14. Let's see if it will work with two strings of 14. 14. Okay, let's see how many volts we will have with one string of 14 as what the voltage is. 39.5 volts times 14. Okay, we have 553 volts in this string. And let's see if the inverter can handle it again. The inverter can handle 600 volts. So we are under this 600 volts going into the inverter, and this stringing will work. We have now the number one, maximum panel modules per string, and number two, we have the strings balanced. So we want the strings balanced to have the same number of panels, or very near the same number of panels in each string. Okay, this will make the inverter more efficient. So that's my mentality for stringing. We now have the stringing for this project, and we can build our electrical diagram as such. Okay, this page 1 is now prepared. We'll talk about the scaling later when we place the drafted project in here, the draft of our home in here. And so we're going to save, and I'm going to copy all of this information, all of the customer information, Control C, so that I can place it on my next few pages. So I'm going to, this is just preparing each page of the project. Again, this lesson is on preparing each page of the project. I'm going to be doing a later lesson. Lesson 3 will be going over the electrical diagram. Lesson 4 will be drafting the home. Okay, so save. We don't want to create a PDF yet, but in order to create a PDF, I'm going to show it to you here, and then I'm going to repeat it later. So File, Export, a PDF. It's going to ask you what type of PDF do you want to create here. This project is 11 inches by 17 inches. Okay, 11 by 17. It's a B-size drawing that you will print out for the city. And so, but here in this selection, you need to select ANSI B 17 by 11. If you do a PDF of 11 by 17, it comes out upside down. It's not upside down, they just have the dimensions backwards. And so for this, you need to select ANSI B 17 by 11. You hit select OK. And in our project folder, it will create a PDF for you. See, it makes all of the area that has any line in it, it makes an 11 by 17 PDF out of it. Now let's try making it into a 11 by 17 instead of 17 by 11. Export PDF. If you select the wrong one, say you select 11 by 17 and you make a PDF out of that. Yes, I want to replace it. Let's see. Now it has made a new PDF. See, now it's 11 inches is the opposite dimension and 17 inches vertically. So we don't want that. We need to create this PDF as a 17 inches width by 11 inches vertically. So this is just creating the PDF of each page. And I will repeat that later because we're going to be creating these PDFs of the data sheets anyway. Some of the sheets we will, again, page 1, 2, 3, I usually just set them up and save them. And then the other pages I do create the PDFs of those data sheets. So let's go on to page 2, the equipment plan. Okay, here's the equipment plan. You'll notice this is the old address. It's trying to pull the other drawing in from the previous project, but that project, it can't find it because it's named Debbie layout. We have Doe layout now. We changed it to Doe. So let's delete that old address there. Let's delete the old aerial view. And again, I'm going to place all of these labels for later over to the side. So right mouse button click, move all of those, and I can move them all to the left. Now, for this, it's very easy. I can just delete what is there, and I can Control V, paste my information from the first page. In this case, it is helpful to have that snap-on because you see what it selects? When you paste it, it selects, you can select that midpoint right there. You know, you just kind of wave the cursor over the area that you want it to snap to. We don't want to snap it to there. We want to snap it to that midpoint. And it'll pull my cursor in. I select it and boom, the information is pasted. So we have the John Doe residence, still owner build. Okay, so that's the customer information. We do that on every page. Now let's move on to this general. So these are just general notes about the project that is required by California. We need to have on the plans. Aerial, okay, this is a main service elevation. This is what the main service panel will look like. We need to keep any main service electrical equipment at least 3 feet away from any gas meter that is there. The phone and TV can be close. Okay. Then we have it'll be the main service panel, the AC utility disconnect, and then we will have our big inverter. And then all right next to each other. And then from there, the conduit goes up to the roof to where the panel arrays are, all the solar panels. And it'll go to a junction box on the roof, and then from the junction box to the panels. And then the electricity travels backwards. So it goes from the panels to the junction box, then to this inverter, then to this AC utility disconnect switch. It's a big switch right on the wall that the fire department can turn off, or anybody can turn off the solar electricity going to the main service panel at any time in case of emergency. And then we have the main service panel. So that's that view. We want to make sure that's correct. If there are 3 inverters, we need to copy and paste and make this look like there's 3 inverters there. Sometimes it's required, if you do have multiple inverters, to have a sub panel collecting all of the electricity from the sub panel to an AC disconnect and then to the main service panel. Okay, let's go on to the aerial view. For this view, I like to paste that JPEG, the roof JPEG that we created. So roof Doe, yes, that's the JPEG I want to place. And I have my snap on, so I snap right to that corner. And I take up as much space as possible and place it. Now I will move. I selected the JPEG, I click the button, and I use my Shift key, and it will lock it so it's exactly horizontal or exactly vertical, and I kind of center it, and I place it, hit the mouse button again, and it places the JPEG. Might take some practice doing that for you guys. Okay, moving on, the section plan. This is a side view of what the home looks like, the structure looks like. Okay, we have the rafters here, and then these are what's called trusses. These are defined as trusses. This is the structure of the home to handle the loads so your roof doesn't fall down. But these horizontal wooden structures are called rafters, and so this is the panel arrays, and these are the attachments that go into the rafters. And so see PV attached with quick mount attachments and unirack rail. Refer to the data sheets for wind and vertical force design characteristics. Okay, we have a 20-degree composite roof. That's correct. If it changes, we need to change it on here. 2x6. These are rafters. I don't know why I had it as truss before. At 24 inches on center. There's our ridge board. There's our eave, 3-foot eave. And typically the roof is 9 foot from the ground to the eave. Okay, moving on. This is just a connection detail of the quick mount that we're using. If you can see, let's pull up the quick mount data sheet. A step-by-step how to install the quick mount attachment. That's what the attachment looks like in real life, and this is what it looks like. If it does not look like this, we need to draw exactly what it looks like. So we have the L-shape attachment, we have this block here, and we have the screw going through, this lag screw going into the rafter. And then on top of this L-shape bracket, we have the rail. The rails will go horizontally across the roof, and then on top of the rails we place the panels. The panels are placed by this sandwich bolt. It's a bolt that connects the rail to the panel internally. So this is a connection detail for quick mount. Again, if it looks like something different, then we need to draw it differently. We need to draw exactly what is there. Okay, then now I move on to, this is a roof load calculation. This is a structural load calculation for the roof. This is just a preliminary one. Some cities require full structural load calculations by a licensed structural engineer, and they require a stamp. Some cities on every single project require a stamp from a structural engineer. In that case, you need to go find a structural engineer in your city, and typically it's $300 to $400 for them to do full load calculations, taking into account the exact structure of the home and taking into account everything else. So this is just a preliminary structural load calculation. We're trying to find pounds per square foot so the city can see just a rudimentary pounds per square foot estimated that the project is going to be. Cities, once it gets above 3 pounds per square foot, they start requiring structural load calculations to verify that this load is not too large for the structure it's on. We don't want the roof falling in on anybody. I'll tell you right now that a lot of city checkers, once it gets above 3.5 pounds per square foot, they start rejecting the plan. And they say either use different modules or different rail system or different structure. A lot of ballasted systems without attachments on flat roofs, they will exceed this 3.5 pounds per square foot. And so a lot of times the ballasted systems with big ballast blocks, probably 32-pound ballast blocks, you know, they a lot of cities reject those type of systems. But for this, let's go through the load calculation. Roof 1, we only have one roof, so we're putting 28 panels there. Single module area, how much does one module take up? Okay, we have our page 1. Let's go back into our page 1 here. Let's open page 1. We did page 1. So we have 64.57 by 39.37. 64.57 times 39.37. 2,542.12 square inches. And we need to change that to square feet. 2542.12. So 2542.12 square inches is how many square feet? 17.65 square feet. Okay, we can close page 1. $17.65 square feet. Now the single panel module times 28 panels. 28 times the area of one panel, 17.65, is 494.2. That's the PV area total, and we can transfer that down here. Those are the total square footage that this load is spread across. Now the panel weight. We had the panel weight at, I have to pull up page 1 again. Panel weight was 37.04. So 37.04. Again, we'll place it up here, duplicate it. Panel mounting hardware is typically 10 pounds per panel. So that's already in there. We have 28 panels. That's 280 pounds for the structure. 37.04. I'm going to try to do the calculations down here for it. 37.04 times 28 panels. 1,037.12. 1,037.12 pounds. Plus 280. Plus 280. 1317.12. Transfer that. So this is total pounds per total square foot. 1317.12 divided by 494.2 square feet. So 2.675. So 2.66 pounds per square foot. Right, let's do that again. 1317.2. 494.2. 2.67. 1317.12. Why can't I get this divided by 494.2 square feet? 2.67 rounded up pounds per square foot. That is correct. Okay, and then we'll go over the scaling again once we bring in the file that we've already drafted. So we can now save this. This sheet is done. I copy this, Control C, save, and I exit that page. Now we're going on to page 3, the electrical diagram. The electrical diagram, we place our customer information here, delete the old information, place new. And so I typically start here. So we have general notes, electrical notes that the state requires about our system. I'll make sure those general notes are in there and that we follow them. Photovoltaic modules. This is a bill of materials. This is each of the pieces of equipment that we're going to be using to put together to install on our solar system. So we have panel modules. We have LG 300 watt, LG 300 N1C. We have 28 modules there. I'm going to change all of this. Number 2, I like to reserve for another piece of equipment, maybe a power meter, a production meter, or batteries, or some other piece of equipment. We do not have a sub panel in this case, so that is 0 quantity. Junction box. We will have 1 junction box for these big inverters. For the microinverters, you have 1 junction box per string. For these bigger inverters, we can just use 1 junction box. And the inverter is a SMA SB8000 TL-US. Sometimes I like to indicate on here we're using the 240 volt version, since there's 2 different versions and we have 1 of those. So if you notice, we have a 240 volt for residential power and 208 volt for 3-phase commercial power. So the numbers are different. So we're doing the 240 volt version. AC utility disconnect. We have 1 of those. We have to see how many amps, which AC disconnect we need. They come in 30 amp, 60 amp, and 100 amp are primarily what you can find on the shelf at the Home Depot or any other electrical equipment store. So we want to have 1 of those. Now next, system ground. We'll have 1 system ground here, that 1 wire going all the way through to this ground, just in case of lightning. It doesn't take out our entire system. The electricity goes through the ground. Bidirectional meter to be installed by the utility company. That is already existing, actually. I just include it on this plan set. So we did the stringing before. We have 14 panels per string, maximum number of panels in the string. This is just general system size information, maximum voltages, maximum amperages that the city requires. Sometimes they require this on a warning placard, but they like to have a box all of its own to view the maximum voltages and amperages. So we will, actually we do, yeah. I'm trying to think if I should do this now. Maybe I should show you right now. Actually, I just want to set up this project, so we'll do all of this calculations later. We'll do all these calculations later. So we'll change this to red. So we don't know those. We don't know the breaker size yet, and since we don't know the breaker size, we don't know this system. We don't know the amperages there, so we'll change those to red. We do know that this is a 200 amp service panel. It is a 200 amp service panel with a 200 amp main circuit breaker. So let's change it to 200 amp main circuit breaker. And there's our main circuit breaker, so 200 amp. That is what is existing. And then if we do calculations and we see that we need to derate this main circuit breaker and put a new circuit breaker in, we will do that later. However, we don't know right now. So we'll change this. The inverter is an SMA 8000 TL inverter. This is maximum electricity that we can put in, maximum current that we can put into this inverter. This is maximum current coming out of the inverter. This is direct current power, this is alternating current power. So we want to look on the data sheets to see what that is. Maximum going in is 24.1 amp per string. This is input. 24.1 amp. Sometimes I like to place that note there. And output is 33.4 amps. That's 33.4 amps coming out of the inverter. An easy way to check the breaker is you multiply 33.4 amps. The city requires a safety factor built in, a 125% safety factor when figuring out the breaker size that you need to stay under. So 33.4 amps times 1.25 times 1.25, that's 41.75 amps. So our breaker size is going to have to be 45 amps. We need to stay under, we need to have a breaker size just over what is the current going in there. So we need a 45 amp breaker. Actually need a 45 amp breaker there, but I'll keep that red just so we verify. We'll do the calculations in the next lesson. Okay, and we don't know the wire sizes, so these are all the labels for the wire sizes. See how it says number 6 wire? We don't know if we need number 6 wire in there yet because we haven't done the calculations. So we change that to red. We do know how many panels are per string. If you don't know how many panels per string, just put it red and then go to lesson 3, and I'll do all the calculations in lesson 3. So we know we have 2 strings of 14 panels each. And we actually need to draw 2 strings of 14 panels. So let's do that now. I select so I want to make a note of selection type. Okay, when you select something, see that blue box? That blue box selects everything inside of that blue box. See, I only selected up to there, and we did not completely encompass these 2 lines, therefore it did not select it. However, if you go the opposite way, there's a green box, and the green box selects everything that it touches. See how it selected that? Even though we did not encompass that line, it selects it. So green box, blue box. Green box is everything that the box touches. Blue box is everything that it encompasses. So you have to encompass that. So I'm going to just select one of these, 2 of these, and I want to make 2 more panels per string here. We'll change that to panel number 13, that's 14, and we can move all of this information. See how I use that? And I'm going to move it over probably right to there. And I'm going to move this line over so we can see it. Now I can extend these lines. This is just drawing what it will look like, and I'm using my snap, so you see I can select those lines and I can hit shift to make sure it's exactly horizontal, and I can snap right to that perpendicular. It's asking me, do I want to snap to the perpendicular? Yes. I just select again. Use shift key. Oh, it snapped to that midpoint. So that's why I don't like snap sometimes. So I can control Z is undo, and I can redo and snap to that perpendicular. I take my 13, 14. So now the panels look like the system is going to be, how the system is going to be. So that is what our system is going to look like. 2 strings of 14 panels leading to a junction box, leading to an inverter, leading to an AC disconnect, leading to the main service panel.